All of the problems covered in my videos can be downloaded at statisticsworkbook.com. If you go to the website, click on the PDF. You can download a copy of the workbook for yourself. Also on the website, you'll find links to all of my statistics videos, not just the ones I've uploaded to YouTube. I've uploaded nearly 100 videos that you cannot find on YouTube. So, I do hope you'll check out statisticsworkbook.com. Alright, let's begin our problem. Hello and welcome back. In this exercise we're going to be looking at measures of relationships between two variables. So what we have here, I've got a data set. This is a fictional data set. I just made this up. This isn't a scientific study by any means. We've got a data set on students' grade that they receive in a course, and then the grade that that student has given an instructor on one of these online evaluation sites. I'm sure you're aware. So we want to see, is there a linear relationship? In other words, what's the relationship between how well a student performed and how well they then evaluate their instructors? So what we're going to look at, we'll look at the covariance and the the covariance and the coefficient of correlation. So what we need to calculate here, our notation SXY, we're going to be calculating all of the differences between individual values of x and its mean, multiply by those differences between individual y's and its mean, and then we're going to add all of those together across all of our observations. Here it looks like I only have 1, 2, 3, 4, so n equals, whoops, why did I write 5? N equals 4 observations. I'm distracted in this video. I've been told that my viewers might be more interested in rather than looking at me, maybe looking at this cute little dog who's always right beside me. Justina, hi. She's always distracting me. Anyways, let's. Now I'm not going to be able to finish this video because she's got her ears perked up. She thinks it's time for a walk, and it is time for a walk. But we have to get through this exercise. So let's. Now she's standing up right beside me. Yeah. Okay. Here you go. There she is, everybody. Yeah. Now it's because of her that I'm not going to be able to get through this video. Okay. We need to calculate these differences, multiply them together, add them all up, and then we divide by n minus 1 observations. Okay, so it's a little bit of a slow process. A lot of these calculations in statistics are a little bit tedious, and there's so much room for mistake, but we just have to take our time and crunch through it. The coefficient of correlation then is somewhat easier. Once we already have the covariance, the coefficient of correlation is the covariance divided by the product of the two variables' standard deviations. Now in this exercise, I've taken a bit of a shortcut, and we've been given those sample means and those sample standard deviations. So we don't have to calculate those intermediate steps. Everything is right there and handy. So let's get on with this. My poor pup here needs to get out for a walk. So let me scroll down here and just have a little bit more room to work with. So Him's going to put in some titles, some headers. We're going to calculate 3 columns. First we'll get all of the differences for the x variable, then all of the differences for the y variable, and then here we're going to multiply those together, add those up, and then somewhere down here is where we'll finally have the numerator for the covariance formula. Okay, so let's get started here. I'm going to work with the x variable first. I'm going to start with the first observation and go down to the 4th observation. Here, this is that relevant mean that I'm going to be using, x bar 55.3. So I'll write out the first 2 calculations here just so you have an idea of what's happening. 75 minus 55.3. That will be the first one. So 75 minus the mean, 55.3. Whoops, what happened there? 75 minus 55.3. So 19.7. And the next one then, 68 minus 55.3. So we get that calculator, 68 minus 55.3, 12.7. Okay, oops. So I'm just going to carry on with those same calculations. So the next one is 54 minus 55.3, so negative 1.3. Where's my calculator again? And the last one is 24 minus 55, oops, 55.3. So negative 31.3. Okay, so that's it for the x. Now we do exactly the same thing for the y. So I'm going to start here, and now this is my mean of interest, 5.3. So our first, this is, oops, let me move that over that other way. 8 minus 5.3. So it's 2.7. 6 minus 5.3. That'll be 0.7. Next one's the same, 0.7. And 1 minus 5.3, negative 4.3. Okay, so there we have all of our differences. And now we want to multiply these together. So now I'm going to be looking at 19.7 times 2.7. 5319. Alright, so I'm just multiplying those two, those two, those two, and these two. So the next one is 12.7 times 0.7, 889. Next one is negative 1.3 times 0.7, negative 0.91, and the last 31.3 negative times 4.3 negative, 134.59. And now we add all of those up. So I'm going to start at the top, 5319 plus 889 plus 0.91, that's negative, plus 134.59. So 195.76. 195.76. So that's our numerator up here. 195.76 divided by n minus 1, so 4 minus 1. Of course, that will be 3. So let me divide this by 3. And 65.25. 65.25. So it's positive. We have a positive relationship. As the student's grade goes up, that correlates with a higher grade that they give their instructor. What is the strength of that? Well, 65.25, it's not 0. If it were 0, there'd be no relationship. If it were negative, it'd be a negative relationship. So covariance is a measure of the relationship of these two variables, but its interpretation is a little bit tricky because it can really take on any value whatsoever. So in order to accommodate that and to sort of scale this value into something that is more easily interpreted, we use the coefficient of correlation, which is our covariance, so 65.25, divided by the product of the two standard deviations. So this is 25.6 times 3. And this, if everything's been done correctly, so I'm going to divide that by 25.6 times 3. This should be between negative 1 and 1. Good, 0.85. the coefficient of correlation will never be less than -1. It will never be more than +1. So because it has a well-defined range of values, it makes it easier to understand the scope or the strength of that linear relationship. Because if it is 1, if the coefficient of correlation is 1, it means that it's a perfect linear relationship. So what that would look like, let me just quickly draw a little scatter plot down here. If this is my x and my y coordinates, a perfect linear relationship would be something like this. And it's just drawing a straight line through it. So that's a perfect positive linear relationship. Perfect negative would just be downward sloping. So because we have these bounds from perfectly negative to perfectly positive, it makes it easier to understand just the strength of that relationship. 0, of course, being no relationship. So here I have a coefficient of correlation of 0.85. That's a fairly strong positive relationship. Given that 1 is perfect, 0.85 is really quite strong. So this gives us evidence there's a very strong positive correlation between students' grade that they earn in a course and the grade that they then give an instructor on the website. Now, again, this is fictional data. I just made this up. This is my suspicion is that this is true, but I don't have the data to support that suspicion. So anyways, I hope that this helps make these calculations a little bit easier. They are tedious, as you've seen, but they are useful when you can use this concept of correlation a lot, and we're going to be using it a lot more throughout the course, so or throughout this series of videos. Okay, so I hope that helps. Here's Justina one last time, getting ready to go for her walk. Justina, wake up. Hi, come here. Hi, good girl. Okay, signing off. Thanks for watching. See you again. If I can find the stop button. There we go.